In this example, we want to evaluate the limit as x approaches infinity of a rational function. To find limits at infinity of rational functions, we divide the numerator and denominator by the highest power of x that occurs in the denominator, in this case, x squared. So we want to divide the top and the bottom by x squared. I think it's a little easier to think of this as multiplying by the reciprocal. So instead of dividing by x squared, we'll multiply by 1 over x squared, which is the same thing as dividing by x squared. So now we have the limit as x approaches infinity of the numerator 4x squared over x squared minus x over x squared minus 5 over x squared. And in the denominator, we have 2x squared over x squared plus x over x squared minus 1 over x squared. Simplifying, we get the limit as x approaches infinity of 4 minus 1 over x minus 5 over x squared, all of that over 2 plus 1 over x minus 1 over x squared. And now we can start evaluating the limit. Notice what's happening. X is going to infinity. That means x is getting really big. Think about this fraction. As this denominator gets bigger, the overall fraction gets smaller. As that denominator gets huge, this fraction is actually approaching 0. Same thing here. If the denominator gets bigger, the overall fraction is getting smaller, and eventually, if the denominator is big enough, the fraction will approach 0. So all of these fractions are going away to 0 because the denominators are getting huge. So now we have 4 minus 0 all over 2 plus 0 minus 0, which is simply 4 over 2, or 2.